And of course, we had a lot of people flying by night in 1998, right? That was the big federal deadline. Came along, slapped these things in any way they could. You go out, do an inspection, you see this kind of business going on. What is that? That's his anode header cable. That's what's feeding the power to his anode. It's sitting there flapping in the wind, right? Not going to work. You walk up to a rectifier and you see this. What can you immediately conclude? There is nothing going on here. There is zero CP. I don't need a reference cell or a voltmeter, do I? No. There is nothing going on. For some bizarre reason, you walk up and you see the fuse sitting in the bottom of the box. It's flipped on. This is a rheostat type. It's supposed to be cooking, but nothing is going on. Okay. You walk up to the rectifier. Somebody has shot it with their pellet gun, and the switch is off. Nothing's happening. But look at what it says. You look at it, and it looks like I have 4.5 amps going on here, right? 4.5 amps is good, right? It can't possibly be putting out any amperage, right? It's not even turned on. Do not ever, third rule of CP, do not ever trust what the meters say on a rectifier. These little cheapo meters are notorious. You cannot trust them at all. You have to measure it yourself with your little voltmeter, and it's very easy to do. Not rocket science. Here is another typical rectifier. This one is turned on. It's on. I'm putting out 60 volts. A voltmeter says that. I can actually measure it. I can connect my voltmeter up to here and measure it directly. 60 volts. Is that cool? I'm on. I'm putting out 60 volts. But look at my ammeter. What kind of amps do I have? What kind of current am I producing? Zero. When you're dealing with impressed current systems, does the voltage really matter to me? No, it really does not have much significance at all. The only thing that really matters to me is the amperage. Am I producing any current or not? The amps are what protects the tanks, not the voltage. The voltage depends on the resistivity in the circuit. The amps is what I'm interested in. Basic rule of thumb, and it is a crude rule of thumb, 1 amp per 8,000 gallon tank. If I do not have at least 1 amp for an 8,000 gallon tank, the likelihood of it actually being protected ain't too good. Excuse my southern. You can measure the amperage yourself. Do not ever trust the meters. If you look at rectifiers, somewhere on the rectifier will always be this thing called a shunt. The shunt is there for you to be able to measure the current, the amperage, with a standard voltmeter. So you connect up your voltmeter across this shunt and you get a number in millivolts. I don't have the time to run through the calculation, but it is a straight, simple calculation. You have to know the size of the shunt, and it tells you what size it is. It's got some numbers on it. This one is 50 millivolts equals 10 amps. That means if I was to walk up there with my voltmeter and measure exactly 50 millivolts across that shunt, I'd be putting out 10 amps. That's what it means. So it's not hard to figure out. Which, incidentally, you look at that, 10 volts, 0.36 amps. 0.36 amps doesn't have much chance of doing anything really unless I happen to be a really well-coated tank. If I had a nice, well-coated tank, I actually could protect it maybe with 0.36 amps, but the more typical scenario is the reason I have an impressed current system in is because my tank is not coated. 0.36 is just not going to do much at all. And I'll just cut it off. All kinds of rectifiers out there. You can walk up to some of them and they have these toggle switches on them. They will default to the neutral position, so the little meter on them reads 0, right? You have to tell it which one you want to measure. Do I want to measure the voltage with the toggle switch? You toggle it down to volts and it will tell you what the voltage is. Go up to amps and it tells you what the amps are. So don't be fooled by some of these rectifiers. There's all kinds of them out there, but they all work exactly the same way. Here is one that's called a constant current rectifier. Looks really complex. Looks really foreign. It's really not. It's the same exact principle. 10 different transformers. Those are the transformers. 10 different diodes. 10 different circuits. Each anode has its own circuit. You can adjust the current to each individual anode. Each one has its own shunt. Each one has its own rheostat to adjust it. So all kinds of rectifiers. Here's a guy, rule number 4, okay? Point number 4 to take from this presentation, if nothing else. Impressed current system, when you see a CP test done on an impressed current system, and you see that they are measuring the ohm potential, and you will see this quite a bit. The only number on this whole piece of paper here is the ohm potential. See it says ohm, and those are the only numbers you see, other than this thing he's calling the native state. And what that means is there's no cathodic protection on the steel at all. It's just plain old steel. But then he has the ohm measurements. That means he took his reference cell, put it in the ground, connected it to the tank, and he measured the potential of the tanks with the rectifier turned on. Does that have any significance to me? It has absolutely zero significance to me. It means absolutely nothing. So when you see something like this, and this happens to be a NACE certified corrosion specialist, this is as high as you can go in the NACE hierarchy, right? And this dude is running around Kentucky, passing these tanks, Kentucky and Ohio, with own potentials. And these are not old test data. These are relatively recent. And this one happens to be from 99, but the guy is still doing this. I know who it is. So you just cannot make any kind of evaluation of a CP system, an impressed current CP system, with ohm readings only. What do you have to do? You have to have what we're calling instant off readings. He actually has a column on this form here for that. He has the off column. Just didn't bother to record anything. The off number is the only one that means anything, okay? This is a really impressive NACE certified engineer again. This happens to be in New Mexico, I believe, and he has a lot of test points over his tank, right? He's got a 2-compartment tank and a tank sitting right beside it. Look what he's got. He's got 10 test points on the single compartment tank, and he's got 14 for the 2-compartment. So, boy, he tested the hell out of it, didn't he? And what he did, he has the native potentials again, some really, really low numbers, but reasonable, possible. You look at his numbers, they're from like 274 to 400 something, 432, 455. And then he's got his own readings, right? He's got own numbers again. Got all these own readings. He's got his native potentials. So what his idea was to take the difference between the own reading and the native potential and come up with a number. There's this thing in NACE that allows you to pass an impressed current system two ways, right? You got the 850 instant off, that's one criterion, or you can do what's called a 100 millivolt shift. If you can shift the potential of the tank 100 millivolts or more, you can declare it a pass. So he took that 100 millivolt shift and tried to determine that by subtracting the native from the on reading. It means absolutely nothing. If you are going to measure or demonstrate a 100 millivolt shift, the only way to do that is to take the difference between the off reading and that negative voltage. That's what he would have had to have done in this scenario. He did not bother to measure the off potential. Therefore, he has no possibility of determining a 100 millivolt shift. And again, someone simply forgot. It appears that the criteria is actually 850 if you're just going by instant off readings. Very nice report, lots of data, but totally disregarded the fact that you got to have minus 850 off in order to pass it. What was peculiar about this particular test, this is in Mississippi, NACE certified corrosion specialist. There were actually 2 rectifiers at this location. This was an industrial plant. They had come in and retrofitted an additional rectifier in an attempt to adequately protect this large tank farm. So when the guy went out to do the test, he very conveniently acted like there was only one rectifier here. He was actually recording off numbers here with one of the rectifiers still operating. Is that a valid test? Of course not. If you're going to test a 2 rectifier system, both of those rectifiers must be interrupted simultaneously. So, okay, piping. How do you test the piping? General rule of thumb again is you test the piping at each end of the pipe. Now, this is where people really get confused about testing piping, and it's that same old story we just went over. They think that it matters where you touch the pipe at. So they want to touch the pipe under the dispenser, and they want to be able to touch the pipe back at the tank. That has nothing to do with it. It doesn't matter where you make contact with the pipe. It is where is the reference cell. So you put the reference cell under the dispenser, and you put the reference cell back at the tank, and that's how you measure the pipe at each end. Okay, so suction systems. This is where it gets kind of bizarre. You've got a suction system for some unknown reason, right? There's still a few around. It's got old steel pipe. How are you going to test the suction piping at the tank? There's nothing but concrete there, right? You can't even see the pipe. You can't get to it. And that's where, again, I'm illustrating the fact that people look at this and go, it's suction piping. I have no access to it at the tank. I can't test it. Yes, you can. When you put the reference cell in the ground over the tank and you stretch your wire out to the dispenser and you make contact with the pipe at the dispenser, well, guess what? You just tested the pipe at the tank end. Very interesting case history. I'm not going to stand up here and talk till 5 o'clock, don't worry, okay? I'm going to let you go. But this is a very interesting case history of what can happen. This was an older location. They came in and they repiped the store. Originally had steel piping. They came in after the impressed current system had been in for a few years, and they repiped it with fiberglass. So when they did that, no one recognized that the negative circuit of the rectifier was bonded to the vent lines. That's a common practice on impressed current systems. They take the negative circuit and they bond it directly to the tank vents. Now, the negative circuit is the most critical aspect of an impressed current system. If that negative circuit is not making contact with the tank or the pipe that you're trying to protect, you actually are intentionally corroding the tank or pipe. You're doing exactly the opposite of what you want to be doing. So in the original scenario, this place was all steel. They came in, they bonded to the vent piping with the negative. The vent lines were electrically continuous with the tanks because they were steel underground also. Everything was steel. But when they repiped it with fiberglass, they had to disturb the vent piping. And when they did that, instead of putting back threaded steel, which nobody does anymore, right? They put in fiberglass lines underground for the vent pipes also. But what did they just do? They just isolated their tanks from the negative circuit of the rectifier. Not hard to figure out, but no one recognized it. So here comes the qualified NACE certified CP tester. He gets some funny numbers, some really funny looking numbers, recognizes that something is not right, and he attributes it to, well, the tanks are internally lined, I can't make good contact with the tanks, and you know what? It's really, really dry. You'll see people throw that out there a lot, right? It's too dry to measure the CP. So he just blew it off and said, okay, that's what it is. Pass. There's his continuity survey, which is a critical aspect of any impressed current test. Continuity surveys are something that no one pays any attention to. Whole different subject. We're not even going to go there right now. What happened is the Mississippi DEQ inspector comes along, and what we always did in Mississippi is we got out our voltmeter and our reference cell and we tested it ourselves. We did not believe anybody's records. We tested it ourselves, and look at the numbers that my inspector gets. Bare steel numbers. Not protected at all. So we write the NOV to the owner, say, your guy came out and did the test 3 months before we were here and he passed it, but you know what? We don't think it passes. It's a fail. Repair it and retest it. So he gets his CP expert to figure out what's wrong. He comes out, does his test. Doesn't take him long to figure it out. Problem with negative diagnosed. Vent lines underground replaced with fiberglass as a result of construction in 2004. Okay, so we finally get somebody out there who can recognize what's going on. It's fixed. We've got all passing numbers. Everything looks great. There's his passing numbers. And you see he's got his on, which means nothing. And he's got his instant off readings all at 850 or more negative. That's the only thing that matters here. But when he's sending in his test with his site drawing, I noticed something else about this. He's got an Act 100 tank. You know, an Act 100 tank is what? It's a steel tank that has a fiberglass wrap on the outside, right? That's what it is. It's a fiberglass coated steel tank. It is actually buried. It was a later installation, obviously. They came back in and they added this Act 100 tank to this facility, and they actually have it installed within the impressed current anode ground bed. There's the ground bed right here. There's the Act 100 tank. Here's the old bare steel tanks. He recognized, the engineer recognized, it is not connected to the impressed current system, the Act 100 tank. Anybody who knows anything about tanks knows that if it is steel and in the ground, there is a good chance that if it is in close proximity to an anode, that it must be connected to the negative circuit, or you are going to intentionally corrode that tank. So it took me some convincing for this guy to recognize that, even though he's, quote, NACE expert. It took a letter from the Steel Tank Institute telling him that this tank must be protected. So you had to bond it into the system. So the lesson is, do not be fooled by people who believe that things are not bonded into an impressed current system because they've got a fiberglass coating on them. They don't need to be. If it is steel and in the ground and in close proximity to an impressed current anode, it's going to have to be bonded in. I can almost assure you. Crazy stuff. Never thought I would see somebody actually try to do this. This is another NACE certified guy trying to apply that 100 millivolt shift criteria. So he recognized that what he did is he was measuring the sub pump. He was measuring metal at the sub pump, and he's got his reference cell in the manway. He's got his local measurement of 1040. He's got his remote measurement of 596. That's inconclusive, right? Doesn't pass. Didn't meet the 850. So he wanted to apply the 100 millivolt shift. What he had is he had some native readings. He claimed to have native potentials on the metal in the STP sumps. There they are. What he did is he took his native readings that he had and subtracted that from his remote reading to get a 100 millivolt shift. Absolutely no validity whatsoever to it. The point being, again, you see all this crazy stuff that these guys try to do. You have to be able to recognize that it's totally invalid. Any questions? I'm sorry I'm not able to teach you what you need to know about CP in our short period of time, but I think you get the idea. Even with people with card-carrying testers and experts, you have to recognize what's going on, because they will do crazy things. It's up to you. If you want to make a difference, if you want to make it better, educate yourself a little bit, get you a voltmeter, get you a reference cell, check it yourself. Thank you very much.